further ado, I'd like to introduce Tyler Lastovich of Generated Media. Tyler can talk about how synthetic content is created and also his company's collection of more than 2 million licensable artificial people. So take it away, Tyler.
Hi, so I'm Tyler. I work for Generated Media. I lead strategy there. So we're one of the earlier companies that has worked with basically GAN generated photos for a commercial market. So without any delay, we'll get into the presentation itself. So let's just take a moment to appreciate that the person you're seeing on the screen here is fake. I mean, completely fake. There is no part of that person that is actually referenceable from any other image. So that's just a prequel of kind of where we're going with this. This is a live photo that I just pulled from our website. That's something we've already generated. It's upscaled to 3000 by 3000 pixels, and it's pretty impressive for what it is. You can see the details all across the face, and it's pretty indistinguishable from real life. So what is synthetic media? Synthetic media is basically anything that can be created by an automated means. So whether that's machine learning or other AI processes, could be text, images, video, audio, or a combination of all of those things. What have we used ours for? This is probably the #1 question we get is, that's cool, but what can I actually do with it? We've had lots of different customers from all over the world. Some of the examples that we've had, our company's only a year old, but we've seen our images used for 3D projection, avatars, enterprise software, SAP, but quite a few images from gaming of every different type, between mobile, board games, or in-depth 3D games. Anonymity protection is a really big issue with these deepfakes as a category, but more than that, I think these avatars and these images that we have allow, say, journalists to protect their identities, and we've seen that in multiple operations. So picture something that a model wouldn't want to do, such as a criminal proceeding or a medical ad or something along those lines. This is perfect for what we were making because the photos we have don't actually have any model rights or usage rights. So people who buy the photos are free to do whatever they want with them. It's been an interesting ride. So how do we make these photos? Primarily, they're made by generative adversarial networks, which are kind of complex networks where there's 2 parts, and we'll get into that in just a second. So while I won't go in depth on GANs, because it is quite a depthy topic, there's some high-level pieces to know. So first and foremost, you have 2 main parts, a generator and a discriminator. The generator's job in life is to create fakes. Essentially, it's trying to fool the discriminator. The discriminator is a machine learning algorithm that takes in input data. And these input data, in our case, are kind of cleaned and sanitized and labeled pictures that are headshots. And so you're having a generator making something from complete random noise, and it forms an image and then asks the discriminator, hey, is this look like a headshot? And the discriminator says no or yes. If it says no, then the generator goes back and starts again and remakes a whole other image and then asks the discriminator again. It does this over and over and over again, billions of times. And failure data is transmitted to the generator every single time. So it learns a little bit each run. So after a while, it is iterated through to a point where the discriminator can't tell whether that image is real or fake. At that point, the machine learning model is trained and you can output real images. It's worth noting that this technology is improving very quickly. As you can see here in our early training, the photos had kind of some artifacts and kind of wonky features. By the time we launched on Product Hunt to a really good reception last year, with our 100,000 faces project, the faces looked quite passable and they scared a lot of people and it got a lot of noise on Twitter. But today we have much more powerful algorithms and many more techniques, and our faces look very photorealistic. So our actual process itself, we start with nearly 100,000 prepared training images. And to get those, we actually operate a full photo studio. So we have models that we source, we license them, they have model releases, and then this allows us to have consistent environments, consistent facial lighting, and then offer multiple styles. So we do our own makeup artistry, And then we have like fully natural facial styles, because actually the most popular photos we have are with just completely bare skin, so people can do whatever they want after that fact. So once we have all the input data, we upload our models and train them in the cloud. This can take up to a week or longer, actually, if you're doing for very, very high resolution photos. And once that's there, we through a host of follow-on machine learning processes, from tagging, labeling, upscaling, metadata generation, background removal. We can automatically insert false backgrounds or multicolored backgrounds as we go as well. So there's a whole host. I mean, there's probably over a dozen additional machine learning processes we put on these photos. After these processes are complete, we enter productions where we're able to generate as many photos as we really want. It's much more efficient to do these in large batches. And so we typically generate hundreds of thousands at once. It's worth noting that styles can be changed during this period. So we can generate different races or age groups specifically. And that's a new function that we're able to do at the very end of this fall. We have a live and running enterprise ready API. So that's what we use internally to power our internal platform and our external web facing portal, which I'll show in a second. This is important because it's really one of the first times you can specify via command, you know, I want, this is as an example, an Asian male with short black hair, you know, and then you can just immediately get a picture of exactly who you want, rights free, don't have to worry about it. And this is available on demand. We've seen some pretty interesting uses of this so far, you know, integrating with other AIs and other processes. And you can see how this would be a very interesting factor going forward with something like video games, or even an integral plugin for Figma or something along those lines. So here's a quick look at what we actually have live on the web today. We built a full custom platform to host our images and go through the many millions that we've generated. While we host 2.6, it looks like, million on the photo site today, this image was taken yesterday, we actually have generated many million more in terms of delivering products to customers that are unique, and just in examples and trial runs. And as you can see on this interface here, you can go through and select exactly the characteristics you want for face type, head pose, angle, sex, gender, age, any sort of physical attributes you want. This is all selectable, and there's going to be thousands of every single type of person. And it's worth noting as well that we have information and ways to search based on similarity between faces. And so you actually can see the next similar face. As you click one face, you'll see others that are near neighbors to it. So why is it important that we can generate so many photos? It's pretty obvious that we've seen some bias issues in machine learning recently, especially with the kind of interesting parts of facial recognition that have happened with Amazon and the critical outcries that have come from that. So we really need more diverse, consistent data sets for facial recognition, object recognition. Academics need these data sets that aren't scraped from the web. They have to be GDPR compliant. We have a lot of interest coming in for all of these areas. And so the next part that I recently led was packaging up and creating very large, diverse headshots that are balanced for race, gender, and actually it can be mixed in between the two. And so you can have a really interesting set of images that just does not exist in real life, and it doesn't exist anywhere else. And that's especially important to train these other machine learning processes that have a really difficult time with the very kind of skewed data sets that are available today. So this is a very unique resource for many different large companies that are going from there. So this is just the beginning, honestly. We're just getting started with this stuff. We're going to be doing full body generation, animation. We plan to get into movement. We have some of these initial training pieces already in place, and from there we'll go a lot further. You know, I don't think there's anything that's really limiting these generative photographs, and you know, this Synthesia we'll talk about later. I mean, they're already doing all sorts of interesting things. So with the talk yesterday of Epic Games, I think moving more into 3D and projection is really interesting. We've seen a lot of game company interest in the last 6 months And so we're going to probably pursue a lot more of that. And as we do shoot our own photos, it's really important to have more diverse individuals come in. The more number of photos that are high quality from each set of background and race and age group, they all improve our models and they all make the overall output much more clear. So if we want to work with us, work with generated photos. This is my 2-second pitch. All right. Thanks.
All right, thank you. Yeah, and I know at Gato Images, we're already starting to look at using your images and have started to, experiment. I've just been really, really happy with the quality. And I know some of our peers here at DMLA and others in the industry are already starting to work with generated photos to put together projects. So we're really excited to hear more about it there.